Hello everyone, welcome to Embedded Systems course with Arduino. In last sessions, we have interfaced many peripherals including LEDs, switches, buzzers, LCDs, keypads, and saw how we could connect the diagrams, right, or the circuits in Tinkercad and write the codes for it, right. In today's session, we will cover interfacing a DC motor to Arduino through a switch. Okay, we will take a slide switch which we had seen while interfacing LEDs to Arduino. So let's begin and understand what is a DC motor and how to interface it with Arduino and what are the components or requirements for this embedded circuit. Okay, so let's begin. So as you can see, in market normally we get two types of DC motors if you would have seen in toys or some robots and all this. So this is a square shape DC motor which we normally get, and this is a round shape DC motor. These two are the DC motors which we normally get. So what is a DC motor? So DC motor in general, it has an input of, you know, the input will be your some electrical energy, right? So this device has an input of electrical energy, and the output is what? So output, the rotor or the shaft, right? This is the rotor, right? So this is the rotor armature, right, inside, right? And what it does, it gives us a mechanical energy. So it converts electrical into mechanical energy. And this electrical energy is nothing but it is a direct current for this type of motors. It's a direct current, right? So that is why it is called a DC motor or a direct current motor, right? You provide electrical energy to it, and it will get converted into mechanical energy, or the rotor and the shaft will rotate, the armature will rotate, right? And then it can be used to produce various robotic actions, and in toys to drive the wheels and etc., right? So now you see there are two poles, right? You can connect a plus or you can connect a minus, right? So let's suppose you connected a 5 volts right here, you connected a 5 volt here, and you connected a ground here, right? So what will happen, that this will rotate in one particular direction. Okay, so this will rotate in this, you can say in this direction it will rotate, right? Now if you reverse this, if you put a minus here, right, and a plus here, if you reverse the poles or the supply of current, this direction you will see will reverse, it will rotate like this, right? So this is what, if you switch the polarity, the direction or the rotation will reverse it. If it is in clockwise, this will go in anti-clockwise, right? So this is in general a principle of DC motor or direct current motor, how it works, right? But these direct current motors may need, it needs a larger voltage, right? It needs a larger voltage. It can, the requirement may be greater than of 5 volts, but you know that the Arduino, right, the Arduino supply is mostly of 5 volts, or that is the reference voltage, right? So how do we ensure that we are able to drive these motors, right? So how these motors, right, how are we able to drive these motors from Arduino, or we can supply the current through Arduino so that we are able to drive these motors which require higher voltage or supply, right? So for that, what we need a motor driver IC, right? Motor driver integrated circuit. So what this does is, here you have an Arduino, okay? So here you have your Arduino R3, and this will act as an interface to your motor, right? So this will act as an interface to your motor. You provide certain supply from your Arduino to this IC, and the circuit inside this IC, right? The motor driver IC will convert this to a voltage or current levels which the motor require. So that is why we need this IC, and this IC in general in market you will get as L239D. This is the number of this IC, right? In general you will need this. So why we needed this? Because in general this works in certain range of 5 volts, right? And in general the motor may require greater than 5 volts. So this IC has an output supply, right? The output supply for this can go from 4.5 volts to 36 volts. This much supply it can provide to the output which is connected to this IC, right? So that is why we need this L293D IC. This is the use of this. Okay. Now let's see if you see there this is a 16 pin IC. Okay. It's a 16 pin IC. So what are the pins of this IC? So this IC can drive two motors, right? It can drive two DC motors. Why two DC motors? I will tell you. So two DC motors, right, require four pin connections, right, to connect the four poles, right? So what we do is, now this is an input. So you supply from the Arduino high or low voltage to this input, right? It can be either high or low, right? You connect to a digital pin of an Arduino and supply this, right? And you connect this input also to high and low, right? That is what you can do, right? Now based on this high and low, you connect this to one pole of the motor and this input 2 to the other pole of the motor, right? And similarly you will have this side input 4, right, for motor to pole 1, and this input, right, will be used to drive motor to pole 2, right? The output will be connected to the motors. Okay, so I can show you through a diagram. You take this, right? You have your motor and this is connected to this. This is how you drive one motor, and here you will have your another motor. Okay, so if I take this and I connect this is your motor. This will get driven from this output, right? So you took an input, right, from the Arduino, selected it high or low, and then you are driving the output, right, or a higher voltage or a higher current, right, to the motors. This input is used to draw current from the Arduino, right? This is coming from your Arduino, and this is connected, the outputs are connected to motor. Since there are two poles per motor, you are connecting output 1 and output 2 to motor 1, right? And this is motor 2, right? So you are connecting pole 1 and pole 2, right? So therefore only two DC motors you can connect, right? So now what will happen if you connect high and low, right? Let's draw a truth table. So this is your input 1, this is your input 2, right? And this is your output, right? So if both the inputs are 0, it's a break, the motor will not run. Okay, now if you give a 0 or 1, so it will run in one direction, forward direction. If you give a 1 or 0 to this, it will run in any other direction, right, in the reverse direction. And if you give a 1, right, if you give a 1 and a 1, it will again break, it will not run. Okay, so this is what the truth table of this IC is. You are taking two inputs from Arduino, input 1 and input 2, and based on what you supply, you are providing the output, higher level of voltage, higher level of currents to the motor, right? as per their requirement, and you are able to drive these motors, right? So since you have four such pins, input 1 and input 2 for motor 1, input 3 and input 4 for motor 2, so only two DC motors you can connect through this L2933 IC, which is an interface between your Arduino and the motor, right? So that is why we need this L293D in addition to Arduino motors and breadboard and all. So we'll have this motor IC, right, which is motor driver IC, which is used as an interface between Arduino and motors, right? So the circuit inside this is in H shape. It's a H bridge motor IC also. It's known as, right? So that we can see later, but this is an H bridge motor IC. The circuit inside is that it's used to drive in this way, right? Input 1 and input 2 to drive output 1 and output 2, right? And if you reverse the flow, or the reverse the output or whatever you supply on this, right, the input pins, right, that the output will change, okay, and the motor direction will be reversed. So L2390 IC is controlling the direction of the motors, and also it can control the speed. If you provide a PWM signal, right, from your Arduino to this pin, right, it can control your speed, or what is called RPM, right? Rotations per minute, it can control, right? We'll see this later, right? But this is the main use of this motor driver IC. Okay. Thank you for joining.